Okay, kids, we're going to talk about Pythagorean theorem today. Now, I know that all of you guys are familiar with this and work with it before, but I'm not too sure how many of you guys are comfortable proving it, which is why we don't really talk about doing it until now, until this chapter 9. So check this out. I think this is kind of cool. It's actually a really easy way of proving it. Okay, so we have a right triangle here, and you see this leg's called A, this leg's called B. That hypotenuse is called C. Now, this altitude here cuts that into two parts. I'm going to call this part X, and if the whole thing's C, this would be C minus X. Now, let's take a look at, well, we have a couple of different small right triangles here, right? Let's look at the right, well, let's do altitude hypotenuse theorems, right? B is in the leg position. B squared equals what? The adjacent part times the whole thing. So that would be XC. Okay, let's come back to that in a little bit. Let's look at the other leg. A squared, leg squared equals the adjacent part times the whole thing. So C times C minus X. I'm going to distribute. Hey, do you notice something? CX, XC. CX is the same thing as B squared, so we can sub that in. That, my friends, is the Pythagorean theorem. Let's move the b squared over. You know, usually you see it like this, right? A squared plus b squared equals c squared. Voila. What do? We did it with altitude hypotenuse theorems, which came from similar triangles. This is all about similar triangles. Similar triangles gives us a lot of cool things. Okay. So that, I knew you knew Pythagorean theorem, but, you know, so if you have a right triangle, I don't really like that most teachers teach it this way. To me, it's better to say leg squared plus leg squared equals hypotenuse squared. Okay. Now, I hope you realize that the converse works as well. So in other words, if c squared equals a squared plus b squared, then angle C is a right angle. So in other words, if you have c squared equal a squared plus b squared, that means you have a right triangle. All right. I don't know if I'm going to do much for these problems here. You know, rhombus, this one's really quick. Let's draw a rhombus. You got to remember all your properties. Diagonals are perpendicular bisectors of each other, right? So if I call this A, B, C, D, and BD is 14, that means that's 7. AC is 48, that's 24. Find the perimeter. We got a right triangle here, right? 7 squared plus 24 squared equals x squared. If you take out your calculator, you will find that x equals 25. So your perimeter equals 100. The main thing I wanted to show you was the proof. This answer is going to be 5A. I'm not going to do the ladder problem. You can do it yourself and check your answers later. Oh, something I forgot to mention. I guess I should do that. Let's go back to the front. So here, if c squared equals, then you have a right angle. What I forgot to mention was this part down here. If c is increased, so if c squared is greater than a squared plus b squared, that means that side A and B have stayed the same, but side the hypotenuse C is lengthened. That's going to push A and B apart. So if a squared if c squared is bigger than a squared plus b squared, you then have an obtuse triangle. And vice versa, right? If c squared is less than a squared plus b squared, then you have a acute triangle. Okay. So here to classify these triangles, that's what I mean. You want to classify these as acute, uh, obtuse, or right. So here you would do, 10 squared is going to end up being greater than 6 squared plus 7 squared. So if that's the case, that's going to be obtuse. Be careful with this one, because when you first look at it, you say 10 squared is greater than 3 squared plus 5 squared. So it's tempting to write obtuse. But when you look at it, this is not a triangle. You can't make a triangle with these side lengths, not possible. So, because the two short sides have to add up to more than the long side. Last thing I'm going to do is just draw this thing out. You should pause this and try to do this yourself first. So we have the pole. Okay, Woody Woodpecker was standing on the pole, and he was like right here. There's the bird. And that pole broke off and flopped down this way and hit the ground. So it made a right triangle, right? And this end hit 10 away from the pole. Okay. The pole was 17 meters high. So if that's x, this is the top part of the pole, that would have to be 17 minus x. You can do the little Pythagorean theorem now to solve for x. And then you can go ahead and do the rest of the sheet, check the answers with the document that I'll post.